verify the parallel and counter flow. So the first thing we need to do before we start the experiment, we should make an inspection to the all water, to all pipe. Okay, first we check the hot water and then hot water supply, cold return, cold supply. So everything we make sure is already fit. Okay, second we should open the valve. Okay. Open the water pump valve and then the valve supply. Okay, right. So after we open, we will switch on the main plug. And then the equipment machine. Okay, that's all from me. Thank you.
Okay, next step is we switch on the pump and then switch on the heater. After we switch on the heater, we will wait for the temperature to reach 60 degrees Celsius. So after it reach 60 degrees Celsius, we will record. No. We will adjust this first. The hot supply valve and cold supply valve. So for hot supply valve, we adjust the flow rate until
3 liter per minute.
3 liter per minute. So now we adjust. For the cold supply, just like the hot supply valve, 3 liter per minute. Okay. So once the flow rate has stabilized, we will record the data. T1, T2, T3 for both supply. Okay. So once we have recorded the data, we will repeat the experiment but with a different flow rate for the cold water supply, which is 2 liter per minute. 1 and until 0.5. So repeat the same step. Once we achieve the required flow rate, just record the data. That's all from me. Thank you.
Alright, so for this experiment, we have two types of setup. This is counter flow and parallel flow. So we have done the parallel flow setup. So next, we will do the counter flow setup. So how do we change to the counter flow setup? So first of all, we need to close the both supply valve, cold supply and hot supply. And then we check here. So this is parallel flow setup. From the diagram, you can see the hot in is connected to the cold in. So to change the setup, need to swipe this two hose. Need to swipe this hose. Then we repeat the same procedure as the parallel flow setup. Start from here. Okay, for the last part, we need to shut down the machine. So to shut down, we need to adjust the cold supply and the hot supply so that the temperature will lower to 50 degrees. So we check here. The temperature is already below 50 degrees. Then switch off the heater, switch off the pump. Then switch off the main power and close all the valve. That's all from me. Thank you.
Warahmatullahi wabarakatuh, and very good morning. My name is RAHMAN. Today, me and my group members will be presenting the report for lab 5, which is parallel and counter flow. So firstly, we will look into the result. For this lab, we have done both counter flow configuration and parallel flow configuration. So the heat exchanger that we use is concentric tube heat exchanger, and this is the table result for counter flow configuration. The heater tank temperature is set to 60 degrees Celsius. So for each configuration, we had done 4 test runs, and for each run, we keep the flow rate of hot water constant at 3 liter per minute, and we change the flow rate of cold water to 3 liter per minute, 2 liter per minute, 1 liter per minute, and 0.5 liter per minute. And then we record the result for TH1, TH2, TC1, and TC2. So since we are using the TD360A device, the TH3 is the average hot water temperature and the TC3 is average cold water temperature. Next, for parallel flow configuration, we also using the same heat exchanger, which is concentric tube heat exchanger, and the heater temperature is set to 60 degrees Celsius. So for this configuration, we also run for test run, and we keep the flow rate of hot water constant at 3 liter per minute, and change the flow rate of cold water at 3 to 1 and 0.5 liter per minute. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ISHAK bin FUZILAH. I will continue to explain about the discussion of the experiment. The first question for the discussion is using the input and output temperature, create a simple temperature profile chart. We use the parallel and counter flow. The first one is parallel flow chart. We have here, we get the upper line is hot temperature and the lower line is the cold temperature of the water. We get here 59.1 Celsius for position 1. The temperature drop until 56.9 at the position 2. And lastly 54.1 at position 3. For the cold temperature water, we get here 34.5 Celsius for position 1. The temperature we raise until 26.9 at position 2, and at the position 3 is 29.3 Celsius. The second chart is about the counter flow. The hot water temperature we get here is 59.2 Celsius at position 1, and the temperature drop until 57.2 at position 2, and the water temperature drop 54.2 at position 3. For the cold water temperature, we get here 29.3 Celsius at position 1, and the temperature will drop 27.1 at position 2. Lastly, 24.3 Celsius at position 3. Use the chart for the equation in the theory section to calculate the water density for the hot and cold water. We get here heat exchanger. We use concentric tube. The connection is counter flow. The heater tank temperature about 60 degrees Celsius. The first row is about the NH. For the first test, we get 14.33. The NC is 14.332. The density for hot water is 984.6. The density for cold is 996.48. The CP is specific heat for hot water is 4182.99. The specific heat for cold is 4178.8. The QE is 1045.75. The QA is 1044.7. The CEB is 0.998996. Then lastly is N is 14.33. Same goes for the other test, which is test 2, test 3, and test 4. The second table is about the heat exchanger for parallel flow. The heat tank also same at 60 degrees Celsius. The NH for the first test is 14.5.45. The NC is 13.87. The density for hot is 984.75. The rho for cold is 996.53. The specific heat for hot is 4182.99. The specific heat for cold is 4178.8. The QE is 1045.75. QAA is 1002.91. CEB is 0.959034, and lastly is N is 14.6. The others is for the test 2, test 3, and test 4. We get here for test 4 is NH is 7.3, NC is 42.7, rho for hot is 983.44, rho for density for cold is 994.63. The density for hot is 4183.8. Rho for cold is 4177.997. QE is 543.89. QA is 529.19. CEB is 0.973009. Lastly is N for the fourth test is 25. That's all for me. Thank you.
Based on information in the result table, we can create a chart energy balance coefficient vertical axis against heater temperature horizontal axis. So for the graph is about the counter flow. So on the x-axis is heater temperature, on the y-axis is the energy balance coefficient. So on the test 1 we get 1. On the test 2 we got 1.05, and we get the highest on the test 3, that is 1.07, and it become drop to the test 4 become 1.03. So for the second test we get the parallel flow. So for the test 1 we get 0.9. The test 2 we get 1, and the highest for the test 3 we get 1.5, and it become drop on the test 4, that is it become 0.9.
Assalamualaikum, my name is Muhammad HAMYZAN bin ADNAN, and I will present about the calculation for LMTD and heat transfer coefficient. So for LMTD calculation, the formula is TH2 minus TC1 minus in bracket TH1 minus TC1 over ln in bracket TH2 minus TC2 over TH1 minus TC1. So first for the counter flow, for test 1, the LMTD is 30.18, for test 2, 30.25, for test 3, 28.6, and test 4, 26.13. And then for test 1, for parallel flow, the LMTD is 29.43, followed up by test 2, 29.58, and then test 3, 25.39, and lastly 25.69 for test number 4. And then next is the calculation for heat transfer coefficient. So the formula is QE over area times LMTD, and for area the formula is pi d squared over 4, and the area that we obtained is 7.85 times 10 to the power of -5. And for the counter flow, test 1, the heat transfer coefficient is 441,406, for test 2, 369,957, test 3, 288,820, and for test 4 is 254,962. And then we proceed to parallel flow. For test 1, the coefficient is 452,655, for test 2, 378,337, and for test 3, 335,861, and the last one is 269,697. Then this is the comparison of heat transfer between the two heat exchangers, and from the table we can see that the parallel flow has higher heat transfer coefficient compared to the counter flow. That's all from me. Thank you.
Assalamualaikum, I'm AMIR bin Muhammad and I will explain about the conclusion. So from the experiment, we learn to determine which flow gives the best heat transfer between counter and parallel. We learn to compare the effectiveness between two flow, which is counter flow is high coefficient in transfer the heat. Then we also will be able to analyze the result from the experiment and do the discussion between two flow. The experiment have to conduct properly to get the accurate data and avoid the error. So for the last one, the objective of the experiment is achieved. That's all from me. Thank you.